All right, we have two triangles right here. Yesterday we talked about the triangles being congruent to each other, and we had to basically show six things that are equal to each other. We had to show all three angles congruent to each other, and we also had to show all three corresponding sides equal to each other. But to tell you the truth, we don't have to go through that whole entire process in order to show that triangles are congruent to each other. Here's the first thing. This is a postulate, all right? So what's true about a postulate? It cannot be proven. Okay, you don't prove it, you just accept it as fact. Okay, so I can't sit here and say, all right, this is, this is true because of whatever. It's just true. All right, you just accept it as fact. So this is a postulate. So look what's given. Let's actually write this down. A, B, C, D, E, F. My favorite names of triangles, just because I can't think of anything else more creative. Okay, so here's our two triangles right here. I want to show that they're congruent to each other. We don't have to now show that all three sides are, all three angles are equal and all three corresponding sides are equal. We don't have to go through all 6 steps. We can actually narrow it down to just 3 things. If I was able to do this, if I was able to show you that AB and DE were equal to each other, that AC and DF are equal to each other, and that BC and EF are equal to each other. If I can show you just that, I didn't say anything about the angles at all, did I? I didn't say that A was equal to D, I didn't say B was equal to E or C was equal to F. I didn't say anything about the angles. All I showed you is that the corresponding sides were equal to each other. That's all I showed you. You follow me on that? Okay, it doesn't mean that this and this are equal. It means the one side of this triangle is equal to the corresponding side of the other triangle. If that's true for all 3 sides, then what do you think might be true about these 2 triangles? Okay, the angles are the same, but because of what? I'm talking about the triangles themselves. The triangles would be what to each other? Congruent, exactly right. So just with this information, not even knowing anything about the angles themselves, just knowing that all 3 sides of one triangle equal the 3 sides of the other triangle, I can say these 2 triangles are congruent. And we give it a reason. We call it side. What do you think? Yeah, good idea. But instead of writing it out like that, yeah, they let you write it just like this. Okay? Now look, we don't say, listen to me carefully. We don't say SSS. All right? We say what? Side, side, side. But we write it SSS. You get it? So if I ask you a reason, why are these triangles congruent? Don't tell me verbally SSS. Don't say that. What would you say? Side, side, side. Everybody got it? Okay, and again, it's a postulate. It's accepted without proof. All right, so we just believe it. All right? I mean, you could try it. You could take any 3 sides, and if I took like toothpicks or something, or pencils or whatever, something with different lengths if you wanted, and I could take those 3 things and I could make a triangle out of it, and then I could hand it to you, Jasmine. I'll say, okay, take these 3 lengths right here, you make a triangle out of it. She's going to make exactly the same triangle that I did. Okay, there's no discrepancy. It won't look different. She can't take my sides and make an obtuse triangle out of it. She can't take my sides and make a right triangle out of it. She can only take the sides that I give her and make exactly the same triangle that I made. Does that make any sense? Okay, so if all 3 sides are the same, if I have 3 sides, pretend they're different lengths, okay, different pieces of paper or wood or something like that, that you can make a triangle out of, or toothpicks or pencils or whatever. If I have this length, and this length, and then I hand it over to you and I said, okay, make a triangle out of those 3 lengths, your triangle is going to look exactly the same as my triangle. Okay? That's what side, side, side means. We get it? All right, that's pretty easy stuff. This is gonna be used a lot. You're gonna like this actually. Okay, it's gonna be used a whole lot. It's gonna be used as a reason in our proof. Once we say these triangles are congruent, and let's mark them. Triangle what? What do you want to call this one right here? ABC. All right. So you guys aren't any more daring than I am with the names of the triangles. Okay. So, but if I call this ABC, I have to call this what? Yeah, DEF. Now look, why? I can't look at the corresponding angles, but look at the sides. So AB has to be the same as what over here? DE. You follow me? So that DE. BC, this bottom one, has to be the same as what? EF. Do you see how those all match up? All right, so if I have those as my triangles and those sides that are marked equal, this has to be my triangle. Now, I could have called it something else besides triangle ABC. I could have called it what? Triangle, give me something else. Yeah, let's go BCA just to mix it up a little bit. All right. All right, so if I called that triangle BCA, what would I have to call this triangle? EFD. Very good. And that was last lesson, wasn't it? Okay. All right, you with me on that? All right, enough for side, side, side. We're going to do one more, and we're going to maybe do a proof, hopefully. Okay, so let's take a look at these two triangles right here. This is a postulate as well. And we'll talk about what it is in a second. All right, so look what I'm given. I'm given that CS is equal to HB, all right, and we're given that this right here, JS is equal to DB. And we're given something else, not the other side, because then that would be the same exact postulate we just finished. Okay, but they tell you that this angle that's in between the two sides, that's very important. Are you listening? This angle has to be between these two sides right here. Do you see how these two sides make up that angle? And then this angle right here. So if you're given this information, they tell you all this stuff, or for some reason you're able to figure out all this stuff on your own. All right, if they tell you this, or if you're able to figure out that all these things are equal to each other, this again is enough to say that these triangles are congruent. Again, if I did this, what if I had two different lengths, two pencils, right, different lengths or whatever, and I said, okay, the angle between those two pencils, here's the two pencils, you put them together, but the angle between those two pencils has to be whatever degrees. Let's just make up a number, let's say 100 degrees, all right? So Jonathan, if I gave you two different lengths of pencils, and I said the angle between them has to be 100 degrees, guess what's true about this side right here? It's going to be exactly the same. There's no way that you can configure it any other way. Does that make sense? If I gave you a length here and a length here, I'm like, okay, let's make a triangle out of this, but the angle between those two lengths has to be exactly the same. All right? So you're like, okay, here's a pencil here, here's a pencil here. You put them together. The length's going to be the same. Is there any other configuration that you could make besides the one that I did? There's not. Okay, it has to be exactly the same thing, doesn't it? You can't say, oh, well, let me twist it this way and twist it this way. Then your angle would change, wouldn't it? All right, so there's no way that you could have different triangles given two sides here equal to two sides here, and the angle between them, it's very important, okay? The angle between them has to be exactly the same. Make sense? All right, so if you're given this information, now we have congruent triangles. So now we could say these triangles are congruent. What are we going to call this? What do you want to call this first one? SCJ. All right, and so watch. If I go SCJ, what am I going to have to go over here? BHD. All right, so that's, oops, I forgot a little triangle symbol right there. Okay, so there you go. So that's how you would mark those two triangles congruent to each other. Now, there's a reason for that. Look, we're given a side equal to another side. We're given an angle equal to another angle, and we're given a side equal to another side. So what do we think? What do you think we call this? Side what? Angle, side. Very good. But we don't have to write it out like that. How do you think we write it? SAS. Do we say SAS though? No, we say what? I put those in quotes because that's what we say. That's how we speak, okay? Side, angle, side. All right? But you write it SAS. That's the reason that these two triangles are congruent to each other. And that's what we're going to do a lot. We're going to work it out, try to show that triangles are congruent to each other, and give me a reason why they're congruent. This particular reason would be side, angle, side. These are postulates. Okay? They can't be proven. We just accept them as fact. All right, let's stop right. Well, let's not completely stop. Let's do a little tiny proof here, and hopefully we'll see what's going on. All right, we're going to try to attempt a proof here. So this is what they start off. Here's the picture that they start off with. Now, I know these don't come exactly. They're supposed to come to a point, but I was just doing this a little bit quick, a little bit rough. All right, so this is some stuff that they give you, and this is how they're going to start it. You've seen proofs early in another chapter, so they always start off with some given. So let me write the given. It says BC. They actually give you a lot of stuff. They say BC is equal to DC. They say that FC equals EC. And they tell you one more thing. They tell you angle BCF is equal to DCE. Angle DCE. It's all the stuff they give you. And what are you trying to prove? Well, you're trying to prove that I'll tell you what. I'm going to go a little different than what they do. I'm going to have you prove that triangle. This is a little easy, but I'll tell you what. Let's just prove what they're going to do. Man, if I had like 5 more minutes, this would be great, but a little short on time. But we'll hit this a little bit more tomorrow because I'm going to let you do some of these in class tomorrow. So we might do another example to get you going on this. Let's prove what they say, that CFD is equal to angle CEB. All right, let's go through this. Just listen. I'm not gonna. I'm just gonna go through real quick because of our time. First of all, we take what's given and we draw it on our picture. BC equals DC. So I put a little tick mark here, a little tick mark there. That's easy, right? Everybody likes that part of it. FC and EC are equal. So FC. Now, do I put 1 tick mark? 2, because I don't know that this and this are equal, right? I just know that these two are equal, so I put 2. Good. And also angle BCF. Where's BCF? That's this one right here, right? And DCE, this one right here, they're equal to each other. All right, you with me? Let's think about it first before we even write our 2 columns down. And what are we trying to prove? We're trying to prove, I'll tell you what, what we're trying to prove, I'm going to mark in a different color. All right, so we don't know this is true, but we're trying to prove it. That angle CFD, where's that? CFD, this angle right here, right? We're trying to prove that this angle is CEB and this angle are equal to each other. All right? Does it make any sense? There's a couple things that we're going to have to talk about before you can do this. I don't expect you to do this completely on your own right now, but let's just take a look at it. First of all, let's look at this triangle and this triangle right here. Look what I was given. I was given a side. What else? An angle and a side. And this side, this angle, and this side. You see it? Okay. So what do you think is true about this triangle right here? I should have done that in red since that's marked in red. All right. So what do you think is true about this triangle and this triangle right here? They're congruent to each other. Give me a reason. Why are they congruent? Side, angle, side. Now watch. If they're congruent to each other, they just told us the 2 sides and the angle. But what do you think are true about the other angles and the other sides? They're going to be equal to each other as well, aren't they? Tell me something about BF and ED. If these triangles are congruent, what do you think is true about this side and this side? They're going to be equal to each other, right? Tell me something about this angle right here and this angle right here. They're going to be equal. Tell me about angle B and angle D. They're going to be equal. Tomorrow, we'll continue with this. I'm going to give you some reasons why that stuff is true. All right? And so we'll continue with this one tomorrow. We'll start it from scratch again, okay? Hold up. Don't leave. Oh. No, why is everybody saying no? You should say, yeah, I want to work on this stuff. I want to 267 let's just do 8 through 11. Okay, so let's just do numbers 8 through 11. That's page 267. All right, that's easy. It's not even it's a little different than what we did today, but you'll be able to do it. Okay, 8 through 11, page 267. That's all I'm going to have you do today. There's no proofs on this. It's no proofs. Okay, tomorrow we'll work on the proofs together.